transition state theory or the activated complex theory. The theory states how the reactants will be converted into a product. So the reactants should possess a threshold energy and also cross the activation energy, then only it can be converted into the product. In between, the reactants will be converted into an activated complex or a transition state which is unstable. In the next step, this unstable compound will be converted into the corresponding product. For example, the reactants A and BC reacting to give an activated complex in which A partially bonded to B and partially bonded to C. The next step, this will be converted into the product as AB and C. Here, the rate of reaction is given by the rate of decomposition of the activated complex to yield the reaction product. Consider for an exothermic reaction. We know reactions are two types, exothermic and endothermic. In some reaction in which energy is liberated is known as exothermic and energy is consumed is known as the endothermic. So for an exothermic reaction, we can plot a graph. In the x-axis reaction coordinate and y-axis it is the energy. The reactants will be having some threshold energy that is known as ER or the energy of the reactants A and B. It should cross or acquire an amount of energy known as the activation energy EA, so that it will be converted into an activated complex ABC. After that, the extra energy is liberated and the product activated complex will be converted to product AB and C. So the energy gap between the reactant and product is known as the delta E, that is the heat of the reaction. Similarly, the energy gap between the reactants and the activated complex is known as the activation energy for a forward reaction, and the energy gap between the product and the activated complex is known as the activation energy for the backward reaction, represented by EA dash. So here the reactants having higher energy will be converted into the product having the lower energy through the activated complex. Similarly, for an endothermic reaction in which energy is consumed, so the reactants will be having an threshold energy ER, which should cross an activation energy and convert into ABC and convert into a product such as AB plus C having higher energy than the reactant. So the reaction is an endothermic reaction. And the energy gap between the reactant and the product is known as the heat of reaction. Similar to the previous graph, energy gap between the reactants and the activated complex is known as activation energy for the forward reaction, and the energy gap between the product and the activated complex is known as the activation energy for the backward reaction. So for an endothermic reaction, the activation energy for a backward reaction will be less than the activation energy for a forward reaction. So here an expression comparable to Arrhenius equation, and the explicitly shown by the higher the activation energy, the lower the reaction rate at a given temperature. Or we can say the lower the activation energy, the greater the reaction rate at a given temperature.